Okay, so the axis of symmetry, that's the line that cuts it in half. The shortcut for that would be x equals opposite of b over 2a. Must be written as a, vertical line. You can't just skip the x equals part. All right, has to be written as a vertical line. Well, how does that relate to the vertex? Well, of course, that means that the x value is going to be the same, but how do you find the y value? What do you do once you find this x value? What do you do with it? Well, the answer is, if you want to find this part, plug in x to the equation. That's literally what you're going to have to do. So B is involved in the process of shifting the left and right movement here. Yes, it's a part of this process. Now, when A is greater than 0, we know it opens up. When A is less than 0, we know it opens down. The x-coordinate of the vertex is, same thing we talked about, opposite of b over 2a. The y-coordinate is found when you plug in that thing for x in the equation. Just got done saying that. The y-intercept occurs when x equals 0 and is always the point 0, blank. You'll know the x value is always 0, but you have to plug in a 0 to find that y value that goes with it. Now, in this particular question, guess what? This number is always going to be the c value. That means it's at the end of the standard form of the equation of a parabola. That's not true for vertex form. It's not the same thing as k. Okay, I'll put that on here. Not k. So don't assume that it's k. It is at the end of the standard form only. End of the standard form only. So, if we do the opposite of b, right, the opposite of negative 8 over 2 times 1, we get 8 over 2, which is 4. So now we know the first part of the vertex, right? And how do we find the other part? Well, we plug it in. 4 squared minus 8 times 4 plus 6. So that would be 16 minus 32 is negative 16. Negative 16 plus 6 is negative 10. So now we know that negative 10 is the other side of it. The A value here is a 1, so this would be a 1, 3, 5 pattern, positive 1, positive 3, positive 5. Vertex form equation, the A value we know is a 1. I don't care if you write it or you don't write it because, we know that it means the same thing. And we have x minus 4 squared and a minus 10 on the outside. Now, don't tell me that the y-intercept is negative 10. The y-intercept is 6. You're probably going to look at me and go, well, Mr. Stailey, that's not even on my graph. True. It won't show up on this graph. But 4 negative 10 will. And if I use my pattern of over 1, up 1, over 1, up 3, over 1, up 5, right? All I'm doing is following exactly what I just said out loud. Over 1, up 1, over 1, up 3, over 1, up 5. 1, 3, 5. And then duplicate those points to the other side. Matching point to the other side. Then we can draw the shape. And you're right, I don't see my y-intercept because it's way up there. opposite of b, let's see, let's try this again. The opposite of b over 2 times a. Ooh, that's going to be ugly. 2 times negative 1/3. Let's rewrite this a different way. That's negative 2 divided by, and 2 times negative 1/3 is negative 2/3. Well, let's go back to middle school. Keep, change, flip. And the 2's cancel and the negatives cancel, and so that leaves me with 3. Okay, so now we know the first part of the vertex is a 3. How do we find the other part? Plug it in, right? Negative 1/3 times 3 squared plus 2 times 3 minus 7. Nine times negative 1/3 plus 6 minus 7. Oops. I got negative 4. That's a negative 3. Negative 10. Yes. Yep. Negative 4. So now I know that the y value of the vertex is negative 4. The vertex form is y equals. Now the a value does not change. It's still negative 1/3 from the original equation. But we've got x minus 3 squared and a minus 4 on the outside. Your y-intercept is negative 7. And the pattern. Now, starts out with negative 1/3. But then when you multiply that by 3, remember it's the 1A, 3A, 5A method? So just think about that. 1A, 3A, 5A. 3 times negative 1/3 would be negative 1. I know, that's the same thing as negative 3 over 3. And then lastly, negative 5 over 3. So that's kind of an ugly looking pattern. You might actually, if you were to graph it with the pattern, you probably would want to use decimals to graph it. So we can try that. 3 over and 4 down. And the pattern is negative 1/3. So over 1 down 1/3. Over 1 down 1. Over down, let's see, negative 5/3 would be 1.6 repeating. And then you'd have duplicates on the other side. So just be careful when you're doing that, that you... Now, if that's not a good strategy for the graphing and it bothers you and you want to do something else, well, then pick some other numbers and plug them in. See what happens. Hopefully, you could plug in like 6. That should be a nice one. See what happens. You can plug in 0, see what happens there. Get some nice numbers. So continuing on here, we've got opposite of b over 2 times a, which is negative 1 here. So that would be negative 2 over negative 2, which is positive 1. So now we know the first part there. Which we can also start writing this. We know that the a value is negative 1, so we can literally use that in the front. We know that the first part of the vertex is positive 1, so we could put that part in. We do need to go up here and plug in the opposite of 1 squared plus 2 times 1 plus 5. Oh, let's see here. That's negative 1 plus 2 plus 5. That's probably 6. And so we could put that there and on the outside here. Of course, my y-intercept is 5. my pattern is -1, -3, and -5. We can find 1, 6 on the graph and go 1 to the right and 1 down, 1 to the right and 3 down, and 1 to the right and 5 down, and then just simply copy these to the other side. It's really nice when they're nice numbers to deal with. So opposite of b over 2 times a, so that's going to give me a -1. So now we know that. We know that the a value is a 2, and if I know the h is a -1, so we got this part so far. Got to plug in the -1. Okay. So we do that, plus 4 times -1, minus 1. So 1 times 2 is 2, minus 4, minus 1. Oh, let's see here. That's -3. So now I know that. And I can tack that onto my vertex form. We know that -1 is my y-intercept. And my pattern is 2, 6, and 10. 2, 6, and 10. So, let's see here. -1, -3, and over 1 up 2, right? Over 1 up 6, 3. 10 is not going to make it on that picture, so we're just going to duplicate to the other side. And draw our graph. Yeah, that 10 was not going to make it. So on this next one, we've got the b value looks like it's missing. Well, that's because the b value that's in the middle is a 0. You've got your a value right here, right? 3. You got your c value right here at -8, but your b value, which looks like it's missing, is 0. So that means x equals the opposite of 0 over 2 times 3. I know what you're saying, Mr. Stailey. What's the opposite of 0? Still 0. And 0 divided by 6 is still 0. So we know that the first part is 0. And if you go ahead and plug that in, 3 times 0 squared minus 8, you get -8. So now we know that part. So our equation, y equals 3. Now, could I write x minus 0 quantity squared and a -8 on the outside? Yeah, there's nothing wrong with that. Nobody puts x minus 0. So literally, we could simplify that to y equals 3x squared minus 8. Now, wait a second. Doesn't that look like exactly what they started with? And the answer to that is yes, it does. Of course, the -8 on the outside would come here. And if I use the 1a, 3a, 5a method, I would get 3 and 9, and 5 times 3 is 15. And so we can find 0, -8. And go 1 left or right, doesn't matter which way you go first. And up 3. And then up 9, right? So we went over 1 up 3, over 1 up 9. Where's that? Well, there's 5, 6, 7, 8, 9. Dang, all the way up here? Goes up pretty quickly when you have those vertical stretches. Alright, so x equals opposite of negative 6 over 2 times negative 3 over 2. And I know this looks a little bit daunting, a little bit challenging, but if you multiply that 2 and that negative 3 halves on the bottom, you get negative 3. And then it's just 6 over negative 3, which is negative 2. So, not as bad as you think. We know that the first part of the equation has a negative 3 halves. And we now know that the x part of the vertex is negative 2, so that would be x plus 2. We know the y-intercept is 5. We know the pattern is negative 3 over 2. Then I multiply by 3, negative 9 over 2. And take the original one and multiply by 2. That'd be negative 15 over 2. And of course, when you graph it, you're going to use decimals. You're going to use negative 1.5, negative 4.5, and negative 7.5. Of course. Okay, and so we forgot one part. We got to figure out what the second part of the vertex is. Okay, so I got to plug it in. Negative 3 halves times negative 2 squared minus 6 times negative 2 plus 5. So let's see here. That's 4. That's negative 12 over 2. That makes that first term negative 6. And then I've got a positive 12 and a plus 5. So 17 take away 6 is 11. So we have a plus 11 on the end of that equation. So vertex is at negative 2, 11. And we can come back here to negative 2, 11 and start using our over 1 down 1.5 over 1 down 4.5, so that would be down a half, and then 4 more. 1, 2, 3, 4. And then over 1 and down 7.5, there's 3, 6, 7.5. Something like that. So, obviously it looks like that part's going off the graph, so I'm not going to worry about it. I'm just going to be using what I have here. To graph that. I don't need to go further with that.